Hello everyone, myself Sabina Devi, Assistant Professor, Department of Physics. In this video, I am going to explain about bulk modulus of elasticity. In previous video, I explained about elasticity. So elasticity is nothing but, so while applying stress to the body, so while applying force to the body, so it will create strain. That's called elasticity, right? So in previous video, I explained about what is meant by elasticity. So what is meant by stress and what is meant by strain, right? So stress is nothing but the force is applied to the particular area of cross section, and strain is nothing but, so after the application of force, so how much amount of that body gets deformed from its original state. That's called a strain, right? So in previous video, I explained about kind of elastic modulus. So elastic modulus is nothing but stress by strain ratio. So Hooke's law is called as Hooke's law, who states that stress is directly proportional to strain. So while giving stress will be increased, the strain also will be gets increased, right? So in elastic modulus, we have three types of elastic modulus. So one is Young's modulus, rigidity modulus, and bulk modulus. We have three types of elastic modulus, right? So in previous video, I explained about Young's modulus. So Young's modulus is nothing but longitudinal stress to the longitudinal strain, and rigidity modulus is nothing but shearing strain by shearing stress by shearing strain, right? So the meaning of shearing is change in angle, right? Okay. So in this video, I am going to explain about bulk modulus. So bulk modulus is nothing but volume stress by volume strain, right? So what is meant by volume stress? So let us look at this diagram. So here we have, so first diagram indicate the, so without any application of pressure, so it is in the form of square cube structure. So it has some volume V, right? So now the pressure applied to the body will be P, right? So look at this second diagram. So here, so after the application of pressure, the body, the pressure will be applied to the both the areas, okay, right? So it has 6 phases. So all the 6 phases we have to apply the force stress to the all the body, right? So after application of body, the body gets deformed from original structure to another structure. So while applying force is applying to the all over the body, it gets shrinked, right? So the original body will transform to a smaller amount of body, right? So look at this diagram. So here the pressure level is P plus del P. Del P is nothing but change in pressure, right? So volume is equivalent to V plus del V. Del V is nothing but change in volume. So V is the original volume. So change in volume is del V, right? Okay, so the bulk modulus is indicated by B, okay, indicated by the letter B. So it is the ratio of total normal stress by volume strain, right? So normal stress by normal strain, that's called bulk modulus. So bulk modulus B is equal to normal stress by normal strain. So here the normal stress value is F into B. So F is nothing but force applied to the area of cross section. B is the original volume of that body, right? So divided by total surface area into del V. So here the volume strain, the total surface area is, so here the cube body. So total surface area is 4/3 pi r cube, and del V is the change in volume, right? So the application of normal stress so causes change in the volume, right? So the volume strain is the ratio of, so here the volume stress is the causes, here application of normal stress causes change in volume. So the volume strain is the ratio of change in volume to the original volume, right? So here application of stress, normal stress is caused in the change in volume. So the volume strain is the change in volume to the original volume, right? So originally it has volume V, and now after the application of pressure, it gets changed into V plus del V, right? So this is called as the bulk modulus. So in this video, I explained about bulk modulus. So the bulk modulus is nothing but volume stress by volume strain, right? So after before application of pressure, it has volume B. After application of pressure, it gets it deformed into B plus del V. So the change in volume, so here the volume strain will be the change in volume to the original volume. This is called as the bulk modulus. Okay, so we have in elastic modulus, we have 3 types of elastic modulus, right? So depending on the stress applied to the body, So we have three different types, right? So one is Young's modulus, restrictive modulus, and bulk modulus. So we know well known about Young's modulus, right? So while applying stress to the body, the stress will be in the longitudinal mode. So longitudinal stress by longitudinal strain, right? So in Young's modulus we have two different types, uniform bending and non-uniform bending. So at the same time we have different type of elastic modulus called bulk modulus. Bulk modulus is nothing but volume stress by volume strain, right? So next one is restrictive modulus. Restrictive modulus is nothing but shearing stress by shearing strain. That's all. Thank you all.